everyone. We are Group C. I am Huang Junxiang, and below is my teammate Chen Weichen, He Rongyan, Cai Peirong, Li Peirun, and Ma Peixun. Here is our content that we will talk about later. Firstly, my part is understand and discover. Here are the details I will introduce soon. So, what is machine learning relevant? Similar to many other fields such as speech recognition, image segmentation, text generation, and many others. Music generation is hugely influenced by neural network recently. Our aim in this project is to use a MIDI dataset to predict or generate code. Here, we will explain MIDI file format, how to generate text sequence from, and the normalization in the data preparation. Further, we will explain our algorithm and model, and how to generate within the network architecture. Next, data science and machine learning problems. In our project, we will mainly use MIDI dataset to recognize the code. We use textual representation of a piece of music extracted from MIDI file to feed it to the network. Each MIDI file is a collection of tracks containing events. Tracks can be different instruments, but also left and right hand for a piano music piece. Event represents not on or off, tempo, instrument type, meta information about the music, and others. Also, each event contains a tick number and a payload. Tick number is the lowest level time resolution. The tick number of each event describes how many ticks pass from the previous event to the current one. Notions of time in the music is defined using the tick, tempo, and resolution. Tempo is the number of beats per minute. We call it BPM, also referred to as quarter note per minute, QPM. The resolution is the pulse per quarter note. First, describing how many ticks per quarter note being played pass. The higher the resolution, the shorter in time is one tick. The picture below depicts this explanation. This is our mind concept. Input and output will be discussed later. MIDI dataset here will use to train the model how to differentiate or classify the input. After that, model will learn itself to become better and generate the output. Below is the picture of the output. Lastly, how the machine learning react? How can we connect the machine learning with the MIDI dataset? The answer is machine learning algorithm. We will use machine learning algorithm to generate a specific model and training it until it can classify the input precisely, and also we need to prevent the over and under fitting problem. Next part, we will invite another person to introduce it.
One day, a composer working hard to make music ran out of idea. What will happen next?
Until then, She heard a melody, and an idea popped into her head. She decided to use the Python code to generate a new piece.
First, input a music file into our Python code and run the algorithm. Then, the Python code will analyze the music file and shows the emotion, style, era, and culture on screen. Lastly, a new music file will be generated as output.
At last, with the help of the Python code, she finally completes her masterpiece.
However, how does the Python code actually works?
Hello, Professor. This is our plan for the final presentation, final project. We will use the algorithm to generate the new music. Yeah, after we understand how the data science and machine learning will help us analyze the song we provided, we can even use the algorithm called genetic algorithm to help us create a new song. Yeah, what is the real example for genetic algorithm? Yeah, in the right picture you see is a antenna come from NASA, and NASA used genetic algorithm to get the best antenna to help them get a signal. Yeah, so we come back to music. Yeah, as we know, chords are multiple notes played together, and we can stack multiple melodies on top of each other to generate new chords. So first, we can let the user to input their favorite songs and melodies for our algorithm. Yeah. After inputting, it will ask us many times if we like the melody or not. Yeah, just like the heart you see. Then it will keep the good melodies and use others to generate the new ones by cutting and recombining them, and also switching out some notes to generate the new melodies. Yeah, and the obstacle we may face during our experiments, during our coding, for example, is we have to try lots of time to let the algorithm to recognize the codes in the music we provided, or spending too much time to train the algorithm to get a good pattern. After planning with our teammates, we will start to work on realizing our Python code and finally using the genetic algorithm to generate our special melody in the final presentation. Thank you everyone. Thank you, Professor.
And I'm gonna introduce you our second plan which apply to our project, and that is music information retrieval. Music information retrieval is the interdisciplinary science of retrieving information from music and brings the domains of musicology, machine learning, informatics, signal processing, and so on. MIR has various applications in real world, such as instrument recognition, pitch tracking, mood estimation, music classification, and above all of these applications, our main goals are chord estimation, music classification like jazz, country, blues, hip hop, classic, and classification, sad, angry, happy. But how can we do that? First, we input an audio and divide them into parts, then extract chords from these segments. Then use machine learning by scikit-learns or some other modules with k-means or probability and some what we have learned in this class. Then we can get our musical information. However, our biggest concern is we get wrong estimation. So we have to avoid this problem by give enough database or write proper Python code.
Hello everyone, my name is He Rongyan, and I will tell you about what's our team members' job. First, let me take a short time to talk about our team and team members. We are not professional in coding and things about computer science or machine learning before joining this class. However, we study hard for the class. Finally, we now have a little bit know about machine learning. And I will introduce our team members. First one is our team leader, Chen Weichen. When we have meeting online, he leads discussion and respects all team members' prescription. In this video, he is the charge of plan explanation. The second one is Ma Peixin. She is also responsible for plans explanation. Then Cai Peirong and Li Peirun did the part of the simulation. Huang Zhenxiang did the part of understand and discover. The last one is me, He Rongyan, and I did the last part of organization. All of our team members are responsible.